So we saw that we could read and write binary data using this data input stream and the data output stream. But these streams read low level units, right? We can read bytes, integers, floats, characters and so on. But in Java, the data types also include those that the user defines, and these are objects, right? They are large compilations which encapsulate various instance variables inside them. So it will be very tedious if we have to disassemble an object and write its component parts and rewrite it back. So the question is, can we import and export objects directly? So why would we want to do this? So one reason is that we might want to actually save the state of a program on a disk, right? So we might want to save the objects that are currently running so that we can restore the state and run later on. So if we want to do that, then every object which is currently part of our running program has to be saved with the current values of its instance variables. Also, we might have a distributed application where things are running at different places. It could be an internet app or something. So we might want to take an object that's created at one location and pass it to another location. So there are various situations where it's convenient to be able to use objects as the unit of reading and writing, and this is not directly available to us through this data input stream and data output stream. So this ability to read and write objects as a whole is called serialization. So writing an object is called serializing the object, and reading the object, that is taking an object which has been written and taking it and reading it back and reconstructing the object, is called deserialization, and we will see a little later why these words come in. So as you would expect, this is achieved by Java providing a different type of input-output stream. So to write objects, we use an object-output stream. So as before, we will take, for instance, we want to write objects into a file, we will first create a file output stream for that file name, and we would wrap an object output stream. So very much the same way that we would take a print writer and wrap it around for a text output or a data output stream for a binary output, we take an object output stream. And now we have in this object output stream class a very convenient function called write object. So if we have defined objects in our particular thing, then we can just say write object and it will write out the object, right? So the serialization we have to do, I mean, we have to write it out, but we can write out the entire, so this constructor implies that there are various components in an employee object and a manager object. So without going through them one by one and writing them out explicitly, this will write out all the data in an employee and in this manager object onto the disk. And importantly, it will write some metadata about the object. So it's not just the raw data, because then if I want to read it, I won't know what the data is. So it actually writes out some metadata about what these fields are. So to symmetrically get it back, I have an object input stream. So again, I wrap an object input stream, say around a file input stream, so that I can read back objects which had been written into that file earlier by the object output stream. So to retrieve these objects, I use read object. Right? So read object will retrieve them, and it's a sequential process. So if I wrote this and wrote this, then what the first E1 will correspond to the object emp and E2 will correspond to the object boss. So in order to use serialization, right, the class has to allow it. So there is what is called a marker interface. So remember we talked about clonable. So if an object can be cloned, the class of the object has to implement clonable. It doesn't have any requirements in terms of functions. It's just a requirement in terms of indicating that this possibility exists. It's called a marker interface. So here we have a marker interface called serializable, which indicates that this class permits its objects to be serialized or written out using this object output stream. So how does serialization work? So an object output stream examines all the fields and writes out their content. So it actually writes out a description of the object. It's not just a binary dump of the object, it writes out the description of the object. So when you construct an object back, it effectively is like creating an object in the normal sense, right? You normally create an object by calling a constructor and passing the argument. So more or less the same thing happens here. In an object input stream, it reconstructs the object by effectively calling a constructor. So there is an obvious problem here. So what if we have within one object, a nested object. So for example, supposing the manager class associates with every manager object another employee object who is the secretary assigned to this manager. Now in an organization, it is very possible that two managers have the same secretary working for them. So if we now try to serialize a manager object, it will store a copy of the secretary object because that's a nested object inside the manager. But now the second manager who has the same secretary will store a duplicate copy of the secretary object. So we will have the secretary object also will exist somewhere. So then we'll have the original secretary object because there is an employee who is a secretary, so it's presumably represented by an employee object somewhere else, and that employee object is nested inside both the manager and the other manager. So to avoid this duplication, what happens in serializable, inside the serializable interface, which is something that we don't have to worry about, but this write object actually implicitly assigns a serial number to every object that it encounters in the process of writing. So the first time when it writes out an object, of course it associates a serial number and it actually writes it out. The second time when it sees an object, if it has already been written out, it doesn't write out the object and it just mentions that here is a placeholder and this placeholder corresponds to this serial number. So this serial number is the object which I have already written, go and look it up. And when you are reading, you reverse the process, right? So the first time, because remember the first time you will read the objects in the same order in which they are written. So the first time when you recover an object with a serial number, you will actually get a concrete object reference in your code. And then henceforth, when you see a reference to an object which you have already read, you will replace that serial number by pointing to this object that you've already read. So this use of serial numbers to avoid duplication is actually the origin of the term serialization. So this is why this process of storing and restoring objects as objects is called serialization. So some objects should not be serialized. So supposing as a part of the runtime of your thing, you have associated something connected to a file. Now when you reconstruct the object, that file may or may not exist. So this connection to the file, like a file handle, is not something that should be restored. So how do you control this, right? So you can mark some fields as transient. So if you mark something as transient, this is a new modifier, it says that this field should be skipped when serializing, okay? So for example, here we have a class called labeled point. It allows serialization, but it has a field inside it which is a point from some other class, okay, which it marks as transient. So when we serialize a labeled point, this field will not get copied out. So if we want to copy out faithfully this thing, we have to then do something ourselves. So we have to rewrite or override the write object, right? So we write so this is the signature of write object in general, which is given in that output class, the object output stream that we saw before. So we override it. So what we do is we first call this default write object. So what does default write object do? It basically does what write object would have been done in the original class. So it writes out this object with all its non-transient fields as though it was serializing it. Now we are left with the transient fields, and that we have to do manually. So we take the point that is not written out because it was marked transient, and we store the relevant data for that point manually using this write double. So this is basically a binary write, like was available in the data output stream. Now when we read the thing, we have to do the same thing. First we reconstruct, so we have to first of all redefine this read object. So we reconstruct the object using the default read object, which will reconstruct the original object, but in that original object there will be this point field which has no value because it was transient and therefore not saved. So now we read the remaining two doubles that we read, and we explicitly call a constructor for that class to associate a correct reference for this field point, right? So when we have these transient fields, then we use our own customized write object and read object to achieve serializability, but it's under our control. So serialization clearly is something which Java feels is tricky because it forces you to announce that you implement this serializable interface, right? It is generally okay if you are serializing for your own purposes, like a backup and a restore, because you know what you're doing. But if you are sharing data with other developers, or if you're sharing data across a network or something, then there are several problems. One is, of course, that this breaks encapsulation to the extent that if you have serialized an old version of your object and then you change your code and somebody now works with the older versions of the objects after deserializing, there is a mismatch between the objects they are using and the objects that you are currently manufacturing. So there is a problem of versioning. You can actually build in some version control into serialization, but it's not very straightforward, and even there are some pitfalls. So you have to be a little careful when you try to understand the implications of where all your serialized objects are going to be used. Another issue with serialization is specific to deserialization. So what does deserialization do? It means that you take an object which is given to you and you reconstruct it. So implicitly you are calling some kind of constructor function on this object. Now, as anybody who has been exposed to the internet knows, it is always dangerous to take something that somebody else gives you, some piece of code that somebody unknown gives you, and run it. So it may be something which is going to damage your system, right? So it's always a security risk to run some unknown code on your system. So of course, if you're doing it in the first situation here, where you're just recovering a backup that you took, you know exactly what's happening. But if you're taking an object which is constructed by some other developer and you're deserializing it, you should be aware of the risk that you're taking in running code which somebody else has packaged and which you have no access to before you run it, because it comes automatically as a part of that read object thing. So to summarize, with serialization, we can export and import objects directly with their state. So it's not just binary data at a low level of ints and floats and doubles, but the entire object can be sent out and restored. And this is useful for backing up and restoring. It's also useful for sharing data across a network if we have a distributed application. So we use this ObjectOutputStream and ObjectInputStream as wrappers around our file stream in order to write and read objects. So internally, this problem of duplicating shared objects is resolved by using serial numbers, and this serial number is the reason why this is called serialization. We can choose to not serialize certain fields by marking them as transient, and then we can save some information about these transient fields manually by customizing the write object and read object methods for that class. So remember that serialization should be done with care because it carries risks. If the objects that you are working with change in your code, the serialized objects will remain in the old version and they will be incompatible. And when you deserialize an object written by somebody else, you carry the risk always associated with running code which is not known to you. So externally developed code, if you run on your system, then you expose yourself to whatever risk that might entail.